Welcome to the Ideal video series on frequently asked questions. This is a series of short videos to explain how to approach common scenarios, model specialized BMPs, or troubleshoot typical issues. Today's video will discuss the storm inputs in Ideal. Precipitation is the driver for runoff that subsequently moves downstream with associated sediment and nutrients. Selecting the proper precipitation amount and distribution is critical in order for Ideal to provide representative results to match the conditions that the user is trying to simulate. The first thing you want to do before beginning a new model is set up the storm inputs by selecting the location of your project and choosing your simulated storm or annual probability distribution of storms. If you do not do this first, you will be prompted to enter the location when you try to edit your first object. You can access the storm inputs by double-clicking on the storm inputs icon, which looks like a rain cloud and is permanently displayed on the top left of the workspace in Ideal. When opening the storm inputs, you will first need to select the state, location, and region based on the location of your project you are modeling. Under the Location drop-down menu, you will notice several different options. A recent improvement to version 3.0 of the Ideal model included the addition of new storm hyetograph distribution options. You can still use the older SCS distributions, but now we have added newer distributions based on the NOAA Atlas 14 data. These distributions are more representative of observed rainfall distributions. In some cases, they result in more intense storms, and in other cases, in less intense storms. It all depends on the location of the project. The user is allowed to choose which rainfall distribution they want to use. Next, you will specify either a single storm or an annual probability distribution of storms. Regulations will frequently determine the storm that is required in a given situation or if an annual load is needed. The single storm choice will be selected if the user only wants to consider the impacts from a specific storm. For the single storm, a synthetic storm of a specified magnitude and duration is utilized. With the single storm selected, you will notice that there are some preset options under the return period drop-down menu. If you select a preset option, the depth of precipitation is automatically populated based on the location you selected. The depth refers to the actual precipitation during the storm event. It should not be confused with the effective rainfall or rainfall excess, which is the depth of rainfall that actually becomes runoff. If you want to set your own precipitation depth, you can select Other under the return period options and then type in your own precipitation and duration value in the input boxes. Make sure you pay attention to the units. You will also need to choose the storm type when running a single storm. There are predefined rainfall distribution curves for SCS and NOAA Atlas 14 data, so make sure you select the accurate one to reflect your situation. Maps are available for reference in many hydrology texts that delineate storm type based on geographic location. The season is specified as either dormant or growing season. The growing season is the period during which plants will be actively growing and withdrawing soil moisture through evapotranspiration, whereas the dormant season does not have withdrawal occurring by evapotranspiration. This becomes important because dry soil tends to allow more water to infiltrate. The antecedent moisture condition refers to the moisture level in the soil at the beginning of a storm. There are 3 available levels to choose from: dry, average, or wet. The antecedent moisture condition is based on the rainfall that has occurred in the 5-day period immediately before the storm of interest, and whether it occurs during the growing or dormant seasons. An average antecedent moisture condition is generally used for design purposes. The annual probability distribution of storms is selected if the user wants to consider annual loadings. This concept is unique to the Ideal model. A site-specific joint probability distribution of precipitation, season, and antecedent moisture condition is used to calculate runoff and annual loading of constituents. The conditional probability distribution is calculated using historical rainfall data for the selected location and region. For each location, values were determined for the probability that the given precipitation event will occur within 12 possible rainfall ranges, the probability that the given precipitation event will occur in either of the two seasons, growing or dormant, and the probability that the given precipitation event will occur in either dry, average, or wet antecedent moisture conditions. Each of the 12 rainfall depths are run for each of these two seasons for each of the 3 antecedent moisture conditions, for a total of 12 multiplied by 2 multiplied by 3, equating to 72 individual storm simulations. IDEAL runs all 72 storms and calculates runoff, loadings, and BMP effectiveness for each storm. By combining the results of the 72 storms and their respective probabilities, sediment, bacteria, and nutrient yields are calculated at the exit of each subwatershed and at the exit of all BMPs. The extensive statistical calculations are built into the IDEAL model, and the historical rainfall data is hard-coded into the annual probability distribution of storms option. IDEAL uses historical data up to 2018 to calculate the probabilities of 72 storms in the annual simulation. There is another tab in the storm inputs that is for selecting a priming storm. The priming storm is only needed when a wet pond is being modeled. If there is not a wet pond in your model, you may keep the None option selected. If there is a wet pond in your model, you will select the Single Priming Storm option and fill out the appropriate inputs below. The purpose of a priming storm is to set the amount of pollutants in the permanent pool of a wet pond before the actual storm occurs. The user must set the depth of the priming storm, and the decision can affect the trapping efficiency. Typical site designs will be served well by a priming storm of 4 to 10 inches. Here are some things to keep in mind. The priming storm must be large enough to fill the pond higher than the permanent pool in order to deposit enough sediment mass to be realistic. The priming storm should not be significantly larger than the depth required to fill the pond completely, as that will begin to artificially increase the trapping efficiency. The actual storm will always begin with the water surface level at the permanent pool. The concentration or mass within the permanent pool is what will change. This means that the only way to know if your priming storm is large enough is to calculate the volume of your permanent pool and the volume of runoff from a storm with the curve number of the drainage area. Thank you for using IDEAL. As always, if you have any questions about IDEAL, please contact the StormOps support team at info@stormopssoftware.com. Also, visit our website and follow us on LinkedIn to get the latest news on support and new releases.